I'm Andre, part of the NNS team at DFINITY. I'm making this video to show you how to verify a proposal to publish a new version of the SNS to SNS WASM. It's a bit of a mouthful, so I thought I'd start this video by first zooming way out and explaining what that means. On the internet computer, there's the NNS and there are SNSs. The NNS stands for Network Nervous System, and SNS stands for Service Nervous System. The NNS is the DAO that manages the internet computer, and there's only one. The SNS is kind of like a framework or tool for creating DAOs. Anyone can create an SNS to manage anything they like. As you can probably guess, the NNS and SNSs have a lot in common. To really understand this, we need to go over how the SNS and NNS work. The IC is composed of canisters, which are bundles of code and data that run on-chain. The NNS and each SNS are made of a few canisters working together. One of the most powerful features of the IC is that canisters can be upgraded with new code, and NNS and SNS canisters are no exception. Anyone can propose a new version of an NNS canister, and then the neurons can vote on whether to upgrade that NNS canister to that version. If the majority vote yes, the proposal is adopted and the canister is upgraded. SNS canisters have a similar story. One difference is that each SNS can only run code that has been pre-approved by the NNS community. The idea being that, if you're using the IC at all, you probably have some trust in the NNS and you believe it won't behave maliciously. So an SNS that's only made of canister code that's gotten the NNS seal of approval is probably trustworthy too. But SNSs are still independent. While the NNS is responsible for giving the seal of approval to new versions of the SNS canister code, each SNS only upgrades when they decide to. And of course, they decide to via an SNS proposal, which can only be voted on by the SNS neurons. So to upgrade, the new code effectively has to be accepted by both a majority of the SNS neurons and a majority of the NNS neurons. This means that users only have to trust at least one of the two, and there's no risk of the NNS forcing through an upgrade that the SNSs don't want. So anyway, what I have here is the NNS DApp. And on the NNS DApp, you can see all of the NNS proposals, as well as all of the SNS proposals for all the SNSs. What's relevant here for this video is the NNS proposals, because what we're going to be verifying is a proposal to bless a new version of the SNS canister code. So as a little bit of a recap, here I have a little diagram where I have the NNS subnet and I have the SNS subnet. The NNS subnet contains NNS canisters. For example, the NNS governance canister and the SNS WASM canister. The role of the NNS governance canister is to store proposals and things like that. The role of the SNS canister is to store different approved versions of the SNS canister code. So very similar, on the SNS subnet, we have a few types of SNS canister per SNS. So these two are supposed to be two independent SNSs that can each sort of upgrade and do their own thing independently. When someone wants to, here, I'll walk you through the process at a high level. So someone can create a proposal, and this proposal can contain a new version of a particular SNS canister's code. So here I have an NNS proposal to bless a new version of the SNS governance canister's canister code. If this proposal is accepted, then the NNS governance canister sends it over to SNS WASM, which then stores it for future SNSs that are interested in it. And also new SNSs are always created with the latest version as represented in SNS WASM. So someone creates a proposal on the NNS to bless a new version of the canister code. Then if it's accepted, the NNS governance canister sends it over to SNS WASM. Then an SNS, once they choose to upgrade, someone can create a proposal on the SNS to say, please upgrade me to the next version. And then the SNS will request it from the SNS WASM canister and upgrade itself to, the latest version. So that is the entire pipeline of a new version of the SNS. Now, I'm going to show you exactly how to verify the canister code, or a new version of the SNS canister code. And the reason that this is important is because you want to make sure that the new version is not doing something weird or malicious, right? So how to verify that? Well, you're going to verify an NNS proposal, because we're going to verify the code that's being added to SNS WASM for future use by all SNSs. So here I am on the NNS app, and I'm just looking at the proposals page for the Internet Computer, which is where all the NNS proposals are. Then I'm just going to scroll down until I see, here it is. I see a proposal called Blessed New SNS Deployment. And, that's the title of the proposal is Proposal to Publish the SNS Root Canister WASM to SNSW. But the proposal type is Blessed New SNS Deployment, which is exactly what we're interested in. So for the proposal summary, which is everything that's in here, this summary is controlled by the proposer. So in theory, they could write anything they want in here. So you should still look at it and make sure that it's accurate and that it makes sense. But when verifying this proposal before you vote, you should you shouldn't fully trust anything that's written here, because a malicious proposer could write anything they want in here. So what can you trust? Well, what you can trust is the payload section, and this just contains the sort of raw payload of the proposal. So when the proposal executes, which this proposal has actually already executed, because it was voted in, it was executed on July 1st, so earlier today, at 10 a.m. But, in theory, you would be reviewing this before you vote on a proposal that hasn't executed yet, so you can decide, whether or not to vote for it. And then what you would do is you would see, okay, here's the WASM hash. So this is the hash of the new code that's going to be used as the new version of what looks to be SNS root. And that WASM hash, this is relevant because there's actually no built-in way to see the code that would actually run. So the only thing you can do is see the hash of the WASM, which is the compiled binary form of the code. And even the best coder in the world can't tell you anything just by looking at the hash. There's hash is a one-way function that all you can see is this, random-looking series of letters and numbers. But what you can do is take advantage of the fact that builds are reproducible. At least they should be if you're going to vote yes on it. And because the build is reproducible, what it means is that the proposer can share the code that they use to build the WASM that they're proposing. And then you can go get the exact same code that they're claiming to use, build it yourself, and then check the hash yourself. And if the hash of the binary that you built matches the hash here, the code that's running, the code that is being proposed, is going to exactly match the code that you're looking at, the code that you built the binary from. So how exactly do you do this? Well, this proposal was submitted by DFINITY, and so I will tell you the process for verifying DFINITY code, but probably even code that's not written by DFINITY will use the same process because it'll use the same infrastructure, I would think. So what we're going to do is look at the WASM verification section of the proposal, and even though this section is controlled by the proposer, it's included because it's useful, and you can sort of look at each step and verify that it makes sense, and then it just means you don't have to remember exactly how to do it, because you can sort of just check yourself that the steps make sense and are correct. So it's saying get fetch, blah, blah, blah. This is all assuming that you already have a version of the IC repo checked out. So that's exactly what I have here. And then I have some files open, but I will close them to keep it clean. And I'll just follow the instructions. Git fetch. Of course, this just fetches the latest version of the repository from GitHub. And then git checkout, and then this git revision. So I'll run this. The implication is that this is going to be the version of the repository that contains the code that was built and generated the binary that is being proposed here. So then it says to run this script. And for this to work, you need to be running from a Linux machine. So I'm actually connected to a remote machine that's running Linux. It's running Ubuntu. And what this is going to do is this is going to create a instance of, or it's going to start an instance of Podman, which is a open source version of Docker. And then I'll just start running it. And then what that's going to do is it's then going to build pretty much everything in the IC repo. And once it's done building it, it'll tell you about its the hash for each version. So while that's running, I'll just open the script. Build ic.sh it was called, I believe. No, I misspelled build. Okay, what was it called? Oh, build-ic. Build-ic.sh. And you can see, this is a script that you should also verify, because you're depending on its accuracy for the next steps. But in general, what it's doing is fairly straightforward. It's just going to create a Podman instance, which will have be a container that has a very, very specific and reproducible set of very specific environment. And then it's going to just build everything, and then you'll see the hashes for each canister type and many other things. So now I'll just search for the WASM hash in the output of this, and I see this hash does appear next to SNS root canister.wasm.gz. So, in your own time, you can read this script and verify that it does what it's purporting to do, which is build all the canisters and tell you the hashes of the built versions. But once you've done that, then you can trust that this hash is the same, is the result of building the SNS root canister and then hashing it. So what does that mean? It means that now whatever version of the code we currently have checked out is the version of the code that is being proposed. So that means I can now just browse the code at my leisure and look at it and see that it's good, see that it makes sense. But a very common situation is that you already trust the old version of the code, and you're just trying to make sure that no issues or no vulnerabilities have been introduced in between the last version and the current version. Because if there was already a major issue in the old version, hopefully it's not super relevant to whether or not you should vote on this one, because in theory the issue may be shared between both versions. So another thing you can do is run this command, which says show me all of the commits in between this version and AD5, which is the version that we currently have checked out. And this is claimed by the proposer of this proposal, claimed to be the previous version that was running. So to check that, you would go and find the last proposal to upgrade the SNS root canister and verify that that was based on this version in the exact same way that this current proposal is based on this version. And once you've done that, then you would be able to only look at the difference between these two versions and verify for yourself and look at all the changes for yourself. So here, I'll run this command. Oops, I mistyped it. And I see there's only been 3 commits inside the SNS root directory since the most recent version. So then what you could do is just go and do git diff and see, okay, here are all the changes. Oh, sorry, that's not actually what I wanted to do. That was showing all the changes since that commit. What I actually wanted to do is go I'll run this again. What I actually want to do is check out this version. And then do a git diff. And actually I'll do git diff tool head _1. And what this does is it shows me the difference between the current version, which is the head, and the previous version, or the version from one commit ago, which is head _1. And so I see there's been one change to the SNS root /canister/canister.rs file. If we look at the change, looks like this has been moved here. So this macro invocation has been moved here. That's not going to make any difference at all. And then it looks like a canister runtime type alias has been declared, which you could go explore for yourself what the effects of that would be. And then we would just do the same for each of these commits. So I'll do it again, and I'll look at the next one. And wow, now I see this in this commit, there has been 4 changes. So it looks like here, this function change canister now returns something when previously it didn't return anything. And seems as if it's returning some, it's just returning a message saying whether or not it was successful or failed. And it seems like here where this function used to panic, now it's returning an error. So let's look at the next file that's changed. Now it seems like previously, and this looks like this change NNS canister endpoint on root which previously just called, and actually this is NNS root, not SNS root, so this is not even relevant to this MR because NNS root and SNS root are different canisters. But just to give the idea of the vibe that is going on here, I'll make this a little bigger so we can see more stuff on one line. Just to give an idea of the vibe that's going on here, we can see that previously the future was just calling change canister, and now it looks like it's calling change canister and then printing some stuff based on the response, whether or not it was an error or not. So I would say that so far all that we've seen in this commit has been some improved logging and a removal of a panic. Here, seems like let _equals has been added. This was probably required by the CI pipeline because if a function returns a result type, you're not allowed to just do nothing with it. You have to explicitly say, I'm ignoring this result type for now. But since the function has the same behavior as before, pretty much, this shouldn't be a problem, or at least it shouldn't be a new problem. And then here it looks like a comment has been added, and it looks like the same as before. We've, instead of just calling change canister, now we call change canister and then print something based on the result. So now we've just reviewed the second of the 3 and reviewing the third of the 3 commits, which would be this one. It would be pretty much the same thing. I'm not going to do it, but this would be your process for reviewing a proposal to bless a new SNS deployment. Thank you for watching. Everyone would appreciate it, and your SNS would appreciate it if everyone was doing this before they voted yes or no, because the fact that the NNS has to approve all new versions of the SNS means that every SNS benefits from the wisdom of the crowd. There are hundreds of eyes looking at each new version, poking around, making sure that what it does is good. or the more eyes, the better. So that means that once for this to be accepted, so many people have looked at it that if there was an issue with it, it would have hopefully been detected before before the proposal was accepted. And I can even see that the proposal was created on June 28th, and it was not accepted until July 1st. So there were multiple days where people could have looked at these changes and said, you know what, I don't like this. Something looks fishy here. To me, and hopefully to you, nothing looked very fishy about it. But it's not so much about what happens when it's not fishy. It's about the fact that if it's fishy, someone would have noticed. So anyway, thank you very much for watching this video. I hope that you have taken away from it some insight on how to verify an SNS proposal, or specifically a proposal to bless a new SNS deployment. I would also highly recommend you watch the previous video in this series. There's another one from my colleague Daniel Wong that discusses how to verify a proposal to upgrade an NNS canister, which is also very important and also has a lot of overlap with the content of this video, because they both are studying the very similar topic of there's a proposal with a binary WASM in it. You need to build the code and then generate that WASM and then look at the code to see what it does. And in this other video, though, he approached it in a somewhat different way. In the previous video, he looked at the dashboard, the Internet Computer dashboard, instead of the NNS app like I did here. And there's a few other differences. So this other video is definitely worth a watch if you're interested in verifying proposals, especially if you're interested in verifying NNS or SNS proposals, or upgrading or blessing new versions of SNS or NNS Canister proposals. So thank you very much, and have a nice day.